Okay, hi everyone. So the next example, we're gonna doing complex numbers. So we're gonna use complex numbers to find our general solution, CF, your complementary function. So here we are required to find CF, your complementary function of the following equation. So say you have dy squared over dx squared, okay, plus 2 dy over dx plus 4y equals to 0. So we only find CF when the equation is equated to 0. If it was equated to a function, you're gonna find a particular integral. So now you convert everything to m, so you let m equals to dy over dx. So now here we're gonna get m squared plus 2m plus 4 equals to 0. So the factors for this, you cannot find the factors for this, so you need to use what is called complex numbers. So basically we're going to use a quadratic equation to find the factors here. So you're going to say m equals to minus b plus or minus, this is a quadratic formula, and then b squared minus 4ac all divided by 2a, and then so your m is equals to minus, so your b is 2 plus or minus root, and then you're going to say 2 squared, okay, minus 4 into 1, which is your a, multiplied by c, your c is 4, all divided by 2 multiplied by 1. This one is your a, okay. So your m is gonna be equals to, so I'm gonna start by this 2. I'm gonna start by doing this. So basically what I'm gonna do there, I'm gonna say minus 2 over 2 plus or minus, I'm gonna split the sign, and then here when I add these values, I'm gonna get a negative square root. So basically you're gonna get a 4 when you square 2, you're gonna get a 4 minus, then you're gonna say 4 multiplied by 4, you're gonna get a minus 16, all divided by 2, okay. And then your m will be minus 1 plus or minus root of, okay. So you're gonna say 4 minus 16, you're gonna say 4 minus 16. So this is your 4 minus 16. So when you subtract those two, you're gonna get a negative 12 here. You're gonna get a negative 12, all divided by 2. This is what you're gonna get. This is what you're gonna get, guys. Okay. So after doing this, you can say, remember, a negative 1 equals to I. This I means imaginary function. So now we're gonna say let square root of minus 1 equals to I. So now in our case, this one here is replaced by minus 12. So now we're gonna go and say m equals to minus 1 plus or minus, okay, we're gonna say root 12 I divided by 2. So if you punch root 12 divided by 2 on your calculator, you'll get the answer. You'll get root 3. Okay, you'll get root 3. Get root 3. So you can leave your answer in this form, or you can say minus 1 plus or minus root 3I. Okay, so after doing this, guys, after finding your values, let's just write them here. Remember, this is your m1 or m2 because it has got a plus or minus. So here you got your minus 1 plus or minus plus, okay, it's minus 1 plus or minus root 3I. This sign right here, it means you've got two values of m. So you've got m1 equals to minus 1 plus root 3, or m2 equals to minus 1 minus root 3I. Remember to put that I there. Okay, so since your factors are complementary, are complex numbers. So if since your factors are complex numbers, so you're gonna use this equation to find your CF. You're gonna use this equation right here. You're gonna say y equals to e to the power x ax, then c1 cos bx, okay, plus c2 sine bx. Okay, so after doing that, remember this equation, this m, you can write m equals to a plus or minus bi. This is your initial equation. So your a in this case is -1, and then your b in this case equals to, as you can see, your b is √3. So you're gonna go and say ycf equals to, so you're gonna go and say ycf equals to e to the power of minus a, which is 1, minus 1, which is your a, to the power of x, then your c1 cos, our b is √3 x, plus c2 sine √3 x. So this is your final answer. This is how you find your answer when you have complex factors. Okay, so the next example, you are required to find CF, your complementary function, general solution of CF. We normally write it as YCF. You are required to find a general solution. So of this equation, you have got dy over dx squared minus 16y equals to 0. So as you can see, guys, remember I said let dy over dx equals to m. So we're gonna substitute m here in this equation. We're gonna substitute m in that equation. So you're gonna get m squared minus 16 equals to 0. So you're gonna say m squared equals to 16, okay, and then your m, you're gonna square both sides. You're gonna get root of 16, and then plus, remember a square root has got plus or minus, so your m1 will be a plus root 16, which is 4, and then your m2 will be minus 4. This one will be minus 4. Okay, so guys, look at the difference. So here your factors, although your factors are the same, but then the signs are not the same. So in this case, you cannot use this equation right here where your factors are the same and the signs are the same. Here in this case, the signs are not the same, only the factors are the same. So you cannot use this equation. You cannot use this equation right here to find these factors. You cannot use this equation where you multiply by x, where you multiply one equation by x. You cannot use this equation because your signs, the factors of your signs, it's a plus or minus. It's not, they are not the same. But if they were the same, if the signs were the same, then you're gonna use this equation where you multiply by x. So in this case, you're gonna use the standard equation. Your YCF will be C1e m1x plus C2e m2x. You don't multiply by x, so you're gonna substitute those values. Again, you'll get C1e to the power of minus, okay, let me just start with the positive one, positive 4x, okay, plus C2e minus 4x. This is how you find it. This is how you find your factors. This is how you find your factors. So after finding this YCF, then you are done. You're done. Hi. So the next topic is particular integral. It's what we call particular integral. Particular integral. Particular integral. so they normally write this as your pi. So I'm gonna do the rules of particular integral. So basically I'll just write one equation, just a random equation, dy over dx squared plus dy over dx plus y. In this case, for particular integral, the equation is equated to q. This q means it can be any function. It can be a number, 4x, or 4x squared, or sine x, or cos x, or your hyperbolic functions, which is your sinh of x or cos x. These are your q. Your q can be any of this, or it can be even e to the power ax. It can be any of this. It can be any function. This is why. Remember, for your complementary function, this was equated to 0. So in this case, it's going to be equated to something, to a function. So okay, let me just do one example. So the first equation, it's when this dy over dx, when your m squared, remember your dy over dx equals to m, so you let your dy over dx equal to m. Okay, so it's your m plus 1 equals to, so the first equation, it's equated to constant, a constant, so it's equated to 4. Okay, so to find your pi, as you can see guys, this is equated to a constant. So if your equation is equated to a constant, you use this ypi equals to, so you're gonna look at your equation, your variable on the right hand side. So just because it's equated to a number, it's not equated to 0. So you're gonna look at that number. So as you can see, it's equated to 4. So our equation for ypi is gonna be a. A means you only have a constant, you only have 4 alone. So this 4 is replaced by a. So let's do the next one. So let's say the next one, your ypi was equals to, let's say instead of 4, you write 3x. It's equated to 3x. Please note that this ypi is the left hand side of your equation. So if you get equation like this, when you write your ypi, you're gonna write, you let a constant be a, so you're gonna say ax. Okay, so the next one, let's say your ypa, your whole equation, this left hand side equation was equated to a quadratic equation, 3x squared plus 4x plus 6. So when you write your ypi, when you write this on the equation to find your ypi, which is your particular integral equation, you're gonna let this equals to, remember, you replace this. For quadratic equation, you know that ax squared plus bx plus c is your standard equation. So this a is gonna be this 3 is gonna be replaced by a. So you're gonna get a x squared plus b, you replace 4 by b, x plus c. Okay, this is how you do it. Let's move to the next one. So your fourth example, example number 4, your equation, your ypi can be equated to 3e to the power of 2x. So when you write it on your ypi equation, you're gonna say ypi, so you're gonna replace this 3 by a constant a, so you're gonna say a e to the power of 2x, to the power of 2x. You write this 2 here, write it as it is, this exponent, you write it as it is. These equations, you use them to find your ypi. Okay, then the next equation, we're gonna do the applications after this video. So the next application is ypi equals to, when your whole equation is equated to a trigonometric function. So you say you have 3 sine x. when you write it on your YPI equation, you're gonna say equals to you're gonna write this equation right here. It's a cos, this a, it's a constant, a cos x, and then plus b sine ax. You write a there. So your a in this case it's 1, so a equals to 1, and then a and b they're equals to 3. This a and b they're equals to 3, that constant there. Okay, so the last one is your hyperbolic function. So your YPI is equated to 3 cos x. So when you write this YPI, it's gonna be, when you write on your equation, your YPI is gonna be a cos x ax plus b sin ax. This is how you write your particular integral equations. These equations, they mean that just because your dy squared over dx squared plus dy over dx plus y equation is equated to a number or a function. It can be equated to any of these values that I just wrote here. It can be equated to any values. No, it's not equated to 0 like the previous example that we did for CF, where you have to find CF alone. No, this one is equated to something. So, and then we said let that equation on the right hand side be Q. So all these equations that I just did here, they're equivalent to Q. So here, if you have got Q on your right hand side, you have to find your PI and CF. So you're gonna have to find your CF and your PI. Okay, so today we're gonna be doing differentiation, second order differential equations, where you are required to find the general solution. So for this equation, from the previous videos, we are required to find the general solution, but then our equation, this whole equation, it was equated to 0. Here. So in this case, it's equated to a function. So now we'll let this 3 equals to Q. That's your Q. So as you can see, that's because this equation is equated to a function. So here you are required to find, in order to find your general solution, your ygen, this ygen s, it means your general solution. So your general solution, you have to find your CF equation and your PI, where this CF is your complementary function, and then this PI is your particular integral. So to find those values, you're going to go ahead and let dy over dx equals to m. So you're going to say m squared minus 4m plus 3 equals to 0. So you're going to ignore this 3 and equate it to 0 to find your factors. So you first find your factors, because the first equation that you need to find is your CF. After finding your CF, you go and find your PI. Okay, so the factors of this, I'm gonna open the bracket there. It's your m minus 1, m plus, m minus 3, m minus 3 equals to 0. So your values of m1 equals to 1, and then your m2 equals to 3. So now you're gonna go and say YCF equals to, you find your complementary function equation, then you're gonna get C1e to the power of m1x, okay, plus C2e m2x. So YCF will be, we substitute those values of m, then your y will be, as you can see guys, these factors are not the same. The factors of m are not the same, so you use this equation if they are not the same. I did do the introduction from the previous videos where you don't have where your factors are not the same, so you should go back and check that video. Okay, so your m1, it's 1, so you're gonna get x there, plus c2 e to the power of m2 is 3x. This is how you find your complementary function. So after finding your complementary function, you go ahead and find your pi. After finding this, you go ahead and find pi. Remember from the previous examples, just because of your equation was equated to 0 here instead of 3, so you stop here, you stop here. So just because it's equated to a number or a function, you have to go ahead and find your pi. So to find your pi, you're gonna go and say y pi equals to, remember it was equated to 3, so instead of writing 3, you're gonna write a. You're gonna write a. This a represent a constant, so you're gonna say y pi equals to a. You remove that 3. You don't write 3. You write a. So you're gonna say dy over dx equals to, you differentiate with respect to x. So remember your basics of differentiation. When you differentiate a is a constant, so when you differentiate a constant, you'll get 0. And then after finding dy over dx, you go ahead and find your second derivative. So you go ahead and find your second derivative, so you're going to differentiate 0. So when you differentiate 0, you'll get 0 again. So after finding those values, remember you go back to your original equation, which is this one. So in this case, you go back to original equation. So your original equation was dy squared over dx squared, okay, minus 4 dy over dx plus 3y equals to 3. This is your original equation. So you're gonna go back and substitute these values, your dy and dx and your y in your y. Okay, so let's go back and substitute those values. So your dy over dx squared is equals to 0 minus 4 into your dy over dx, it's 0 again, plus 3 multiplied by, what is your y? Your y is a. Your y is a. So you're gonna say a here, then equals to 3. So all this will be 0, and then you get 3a equals to 3. So you find your a will be 1 when you divide by 3 both sides. So you're gonna get 1. So you go back to this equation, right here, your ypi. You go back and substitute that value of a there. So we'll say ypi equals to a equals to 1. So your ypi will be equals to 1. So remember, we are required to find the initial equation. We are required to find a general solution. You're required to find a general solution. You're required to find this general solution. So your general solution, you're gonna have to add your ycf and your ypi. So your ygen will be equals to your ycf plus your ypi. So your ygen will be equals to, remember your ycf, you did find your ycf earlier on, so it was c1e to the power 3x plus c2e to the power x plus that one ypi equals to 1, remember. And then your ycf was equals to this 2 right here. This is your ycf. So this is how you find your general solution when your equation is equated to a function. Hi. So the next example, we are required to find general solution of the following equation. So first thing first, as you can see, your equation is equated to 3x. So before doing anything, you're gonna go, you must know that you are required to find pi and cf here. So your general solution, your y gen is equals to the combination of ycf plus y plus ypi, just because your equation is equated to a function, so it's ypi there. So now you're gonna go and say your ypi, in this case your ypi equals to 3x equals to ax. So where there's 3, you replace it by a. Okay, so first thing first, dy over dx equals to m. So where there's dy over dx, you're gonna put m. So you're gonna get m squared minus 4m plus, okay, I forgot to put 3y there, plus 3 equals to 0. So you ignore this value of 3x. So you find your factors. So first thing first, you're gonna have to find your YCF, and then after finding your YCF, you find your YPI. So to find your YCF, you're gonna have to find factors first. So the factors of this, you'll get m minus 1 and minus 3 equals to 0. So your m1 equals to 1, and then your m2 equals to 3. It doesn't matter, you can say m1 equals to 3 or m2 is equals to 1, so you can do vice versa, it doesn't matter. So now, since your functions, since your factors are the same, so you're gonna use this equation right here. Your YCF will be C1 E M1 X plus C2 E M2 X. Okay, so you're gonna substitute those values. Your YCF will be C1 E, then M1 is 1, then your C2 E, then your M2 is 3. So you're gonna write 3x right there. So this is your equation for CF. Okay, so we are not done. Just because this equation was equated to a function, you go ahead and find your PI. So your YPI, remember I said it was 3x, so now you replace these values by AX, because your A replaces 3. Okay, so after doing that, guys, the next step is to differentiate. So you're gonna differentiate this equation of YPI. So you're gonna differentiate your dy over dx. You're gonna differentiate with respect to x. So remember, you differentiate this equation. So your YPI, you're gonna ignore that 3x and say ax. So you're gonna find the differentiation of this. So the differentiation of that, you're gonna get a. Then after that, you find your second derivative. You're gonna find your second derivative. You're gonna differentiate this a. You're gonna get a 0. So after differentiating, guys, you go back to your original equation. This equation right here, you're gonna go back to your original equation. So when you go back to your original equation, as you can see, guys, this is the original equation right here. We found our dy squared, our second derivative, and our first derivative, and we found our y. So let's go back. Let's write that equation here. Let's just rewrite that equation. So your original equation was d squared over dx squared, okay, minus 4 dy over dx, okay, it's not squared, dy, and then here it was plus 3y equals to 3x. This is the original equation. So now we're gonna go back and substitute those values. So your dy over dx squared is 0, minus 4 into your dy over dx, it's a, and then plus 3. What is your value of y? Your value of y, it's this here. This is your value of y, it's ax, okay, equals to 3x. So now here we're gonna get 4 minus 4a plus 3ax equals to 3x. Okay, so after finding those values, as you can see, guys, the aim is to get a here. The aim is to get a. So we need to find a so that we can substitute this a back to our original equation for pi. This original equation here. We need to go find a and substitute it here. After finding a, you're gonna have to substitute it back to this equation. So as you can see, guys, to find a here, you're gonna go and start with the x term, the highest power. So your highest power in this case, it's x. This x is raised to the power 1. So you start with the highest power. Your highest power is x. So you're gonna go and find the coefficients of x. So you're gonna ignore this one because this one is raised to the power 0. So this one is raised to, it's like minus 4a to the power x to the power 0. So this is the same as minus 4a. So the highest power here is x to the power 1. So we're gonna go ahead and take that value. We're gonna take 3a, okay, equals to, we take the coefficients of this. So you ignore x, equals to 3. So your a will be equals to 1 when you divide. So after finding that a, the value of a, you're gonna go back to your original equation of pi and substitute that 1 there. So you're gonna get 1 multiplied by x when you substitute back to this equation, ax. Okay, so after finding that equation, the next step is to combine our ypi and your ycf. So your ygen will be ycf plus ypi. So your ygen will be, we go back and to your ycf. Remember your ycf, this is your ycf. So you're gonna go and combine them. So your ycf was 3x plus c2 ex. So guys, it doesn't matter even if you swap these values, it's the same. Even if you swap these values, it doesn't matter. Plus, okay, remember your ypi was x. This is here, your ypi was x. So you're gonna go and add x there. Then this is your general solution.